Hello everyone, this is Manish Sharma, and in today's session we are going to discuss the very important topic, which is actual meeting envelope. Okay, so what is actual meeting envelope and how we used with the help of in this feature of size. Okay, so it is very important to understand. So what is actual meeting envelope is basically an actual meeting envelope is an envelope. Is an envelope that is inverse of a feature of size that just coincides with the extremities or high points of a feature. Okay, so what is this actual meeting envelope in layman language? If we understand, okay, let's say if there is a part. Okay, so with the help of this example we are going to understand about the actual meeting envelope. So this is a part. Okay, so in this part, if we want to check that what are the high points in this hole. So this part is having a hole. Okay, so this is a hole. If we want to check that what is the maximum size of the shaft can enter into this hole, so what we have to do is we have to create an envelope to check that what size of dimensions is possible to enter into this hole. Okay, so to understand this better, we take this example. Okay, so for hole, and first we will understand for hole, and then we will understand from the shaft point of view. Okay, so for hole, if you see, the actual mating envelope is the largest cylinder. Okay, so this is, let's say, shaft, or you can say cylinder in this case. So the in this is a cylinder. Okay, so the actual mating envelope is the for hole, an actual mating envelope is the largest cylinder that may expand so that it coincides with the actual hole surface at the high points. Okay, if this cylinder enters into this hole and it expands inside, okay, in this direction, it expands in this direction. So what will happen? It will touch the high points of the hole. So let's say this is the high point, this is the high point. So it will touches the high points of the hole. Okay, so that we can find out that what is the maximum size, what is the largest cylinder can enter into this hole. Okay, if we see in this example, okay, so now you can see in this drawing that the shaft or the cylinder has entered into this part in the hole. Okay, so it is touching the maximum points of the hole. Okay, so these are some of the these are the maximum size of hole, the points which are extremities. Okay, so these are extremities points which is touching by this cylinder. Okay, so this is called an envelope. So this is called actual mating envelope. Okay, in case of hole. So in case of hole, the cylinder will be the envelope. To find out the maximum, to find out the largest cylinder size. Okay, so the maximum size shaft or cylinder can enter into this hole. Okay, so so here the shaft diameter, this is the maximum shaft. Okay, so this shaft is the maximum shaft diameter that can enter into this into the hole, because the shaft diameter is touching the high points. This largest cylinder diameter is the actual mating envelope. Okay, so I have already told you this largest cylinder diameter is known as the actual mating envelope. Actual mating envelope for this internal feature. Okay, so for now we are talking about the internal feature. For internal feature we are discussing this. For internal feature means for hole. Internal feature means hole. So this discussion is for the hole. Similarly for the shaft. Now we will understand that what actual mating envelope looks like for the shaft. Okay. So let's say this is a shaft. this is the example for actual mating envelope for the shaft. Okay, so the actual mating envelope is the envelope is an envelope that is inverse. The definition is same. Okay, so for shaft, an actual mating envelope is the smallest hole. Okay, that may contract so that it coincides with the shaft surfaces at the high point. Okay, sorry. So this is the shaft. So this is the envelope. Okay, so this is the envelope in this case. This is the actual mating envelope. So in this case, when the shaft will enter in this point, so the hole, this is hole points contracted. Okay, so this this point, these points will be contracted and touches the high point of the shaft. So this is the high point of the shaft. Okay, so these are the high point of the shaft. So this is the smallest hole. Okay, so this is the smallest hole which can enter into the shaft by touching the high points of the shaft. So this whole diameter is actual mating envelope. Okay, so in this scale, in this example, this whole is the actual mating envelope for the shaft. Actual mating envelope for the shaft. Okay, for shaft. In the previous case, it is for the internal feature of size. This is example for the external feature of size. Okay, so external feature of size, we are talking about shaft. Shaft. Okay, now actual mating envelope basically is of two types. First one is the unrelated actual mating envelope, and second one is related actual mating envelope. Okay, so we are going to understand each of them one by one with the help of example. Okay, so first of all, we are going to discuss the unrelated actual mating envelope. Okay, so now we will see that the unrelated actual mating envelope will almost never be perfect perpendicular to the datums. Okay, so this point is very, very important because the unrelated actual mating envelope will never be the perfectly perpendicular to the datum. Okay, so in this also we are going to understand with the help of example, with the help of shaft and with the help of hole. Okay, so both the cases we will understand that how it is important. Okay, so in the right side of the figure that shows the related actual mating envelope is the largest perfect cylinder that is perpendicular to the datum and fits inside the physical cylinder. Okay. This is the definition. So it is an envelope that is similar perfect feature. It is saying that it is a similar perfect feature counterpart expanded within an internal feature of size or contracted about an external feature of size. Okay. So this is an external feature of size case. External feature of size. And this is internal feature of size. And size and not constrained to any datum. Okay, so it is also saying that it is not constrained to any datum. Okay, so in this particular example, if we see for shaft unrelated actual mating envelope, so this is the datum. Okay, so A is showing the primary datum, so this is showing the datum. Okay, this is the actual design, and if we see, so these are the dimensions, and it is given the 0.3 maximum material condition, which is perpendicular. Okay. Now the unrelated actual mating envelope, I have in this, you can see in this part, you have a boss like structure shaft. Okay. And in this to measure the axis. Okay. If we see the axis of the shaft, axis of the shaft you use as an envelope in this case. Okay, so in this case, this dotted lines, these lines are the actual unrelated actual mating envelope. Okay, and this is saying that not constrained to any datum. That's why this is not perpendicular to this datum. Okay, so this unrelated actual meeting envelope is not perpendicular with the datum. It is not constrained with the datum. Actual meeting envelope not taking the reference as a datum. So this unrelated actual meeting envelope is not taking reference as a datum. So this envelope which is not taking as a reference is called the unrelated actual meeting envelope. This will give the axis of the boss. Okay. If we see the axis in this case, so whatever the axis of this of the shaft will be, so same will be the axis in this case. Okay. So axis will be same for both the cases, for both shaft and the envelope in this case, but it is not perpendicular or not constrained with the datum. Okay. Similarly, we have the in this is the case of cylindrical pin. Okay, or shaft you can say. So that touches the high points. So this is touching the high points of this shaft. So this actual meeting envelope touching the high points of the shaft, and which is not using reference as a datum. Okay, so this is the unrelated actual meeting envelope. Similarly, for the hole also, for the internal feature of size for hole also, in this case, it is also not using reference as a datum. And the shaft hole axis and the axis of the envelope is same. Okay, so what the axis for both in both the cases are same, but it the envelope is not using reference as a datum. Not using reference as datum. Datum as a reference. Okay. Now we will learn about the related actual meeting envelope. Okay. So what about the related actual meeting envelope? So in this you can see related actual meeting envelope is an envelope that is similar perfect feature counterpart expanded within an internal feature of size. Okay. And contracted about an external feature of size, while constrained in either orientation or location or both to any applicable datum. Okay, so in this case you can see that the actual meeting envelope, so in this case this is the actual meeting envelope, related actual meeting envelope, but it is also touching the high points, but in a but taking reference as a datum as a reference. Okay, so in this case actual related actual meeting envelope, the envelope is using a datum as a reference. Okay, so it is perpendicular. You can see it is perpendicular to the, this envelope is perpendicular with the datum. So in this case of if you want to understand this concept, it is very similar to the unrelated actual meeting envelope only. But in this case, the only difference is this: the unrelated actual meeting envelope it does not take any reference as a datum, but whereas related actual meeting envelope takes the datum reference. Okay, it is using this reference as a datum as a reference. So here we have an example of a part like boss. So this is boss. So this is an envelope. Okay. The envelope contracts. The envelope contracts so that the actual meeting envelope, which is taking the reference of the datum surface, in this case orientation with the datum surface is called the related actual meeting envelope. Okay, so this is for both the condition, this is for the shaft or the pin, and this is for hole. Similarly in this part also if we have a hole. Okay, in this is an envelope which expands. Okay, so in this is also, it is touching the high points. So this envelope is basically touching the high points, touches the high points of the hole. At the same time the surface is perpendicular. Okay, so this datum surface, it is using datum as a reference, is perpendicular to the top surface. Okay, so this envelope is perpendicular to the top surface, so it is taking as a reference datum. Okay, So this is also the example of related actual meeting envelope. So this is all about the actual meeting envelope. Hope you understand the concept of actual meeting envelope. If I summarize this actual meeting envelope, so basically it is of two types: unrelated actual meeting envelope and related actual meeting envelope. In unrelated actual meeting envelope, we do not use, never use the datum as a reference, okay, for the envelope. But in difference between the related actual meeting envelope, we basically use the datum as a reference.